Okay, so here's a problem that's dealing with three masses on a massless rod rotating around the center object. And the first thing they want to know is what's the torque on the system by the force that's shown. So we know that torque equals RF sine theta, where R is the distance from the rotation point to where the force is applied. So in this case, it's 2 meters. The force we have is 8 newtons. Sine theta, theta is the angle between the force and that line to the center point, which is actually 90 degrees in this problem. Sine of 90 degrees is 1, and 2 times 8 is 16, so the torque is 16 meters times newtons. Then they want to know about the rotational inertia of the system. Well, our rotational inertia equation is the sum of mr squared. So we have to take each mass times how far away it is from the rotation point squared. Well, we have three masses, so we have m1r1 squared, m2r2 squared, plus m3r3 squared. m1 is given as 4 kilograms, and m1 is 3 meters from the rotation point. m2 is 3 kilograms. m2 is at the rotation point, so the distance there would be 0. m3 is 5 kilograms, and the distance from the rotation point is 2 meters. So we go through the algebra, and we find that I is 56 kilograms times meter squared. And then finally, they want the angular acceleration. So we know that just like F equals ma, so torque is 16 meter newtons. I is 56 kilograms times meters squared. So we can solve for alpha doing some algebra, and we get 0.286 radian per second squared.